Hi, we are the Autopilot dashboard team. Welcome to our demo number 5. IBM Autopilot is a Kubernetes native daemon set designed to monitor GPUs, evaluate them, and also run tests. Our vision is to add a fully functional UI dashboard to Autopilot, allowing users to easily monitor each GPU and each node and quickly interactively deploy various health checks and tests on the GPUs.
One of the things that we worked on for this sprint is improving the Kubernetes Watch API to handle errors and interruptions. We added a reconnection logic for whenever there's an error or network interruption during streaming. We utilize the resource version field, and this represents the version of a resource, which enables tracking for every Kubernetes objects. With this, we are able to ensure that information from Watch is not stale and that during the events of interruption, Watch can continue to the previous version without having to do a full refresh unless it's needed to reduce overhead.
For our login system, we deployed a Keycloak server along with GitHub OAuth app. And here in the video, we see I'm logging in with my GitHub account. I authorize it, and I have full admin permissions, so I'm able to, of course, monitor the cluster, monitor the different nodes. I'm also able to run tests, as you saw there. The run test button was enabled. We also have role-based access control set up through our Keycloak server. Here I'm in an admin account, and of course I'm able to run tests using this account. Admins have full privileges of running tests and also monitoring nodes. But now I'm going to go on to a user account without admin privileges. The username and password is autopilot-dashboard. So this is, if you would like to monitor our nodes, monitor our system, feel free. And as you see here, that account does not have run test privileges. So the role-based access control is correctly implemented.
So in this video, the user tries to enter their credentials on the login page and it attempts to access the restricted area. But since the user doesn't have the necessary permissions, they're immediately redirected back to the login page. And then this assures that Autopilot as a whole stays safe. And then for the architecture I made, when a user logins, their metadata, such as their user ID, login, and like their timestamps and everything, they're sent to a database where everything is just captured. So once you log in, if your data is in the database, you will be authorized and you'll be able to access Autopilot. If not, like in the last video, you will just be redirected back.
One thing we worked on this sprint was installation in the form of a Helm chart. So our mentors requested a Helm chart that is configured around the container image of our dashboard. Helm is a package manager for Kubernetes that is used to deploy applications, and it simplifies deployment and management of the Autopilot dashboard in Kubernetes clusters. The installation process is packaging configuration templates into a reusable Helm chart, and we deployed the chart using Helm install, which automatically handles Kubernetes object creation. Now I'm going to demonstrate downloading the Helm chart. So here I'm downloading the Helm chart called Autopilot Dashboard. I'm going to check the status of it to get the name of the pod. I'm going to forward it to my local port. If we go to localhost 8080, here is our dashboard. This is the old login version because this is the login page for the general environment.
This sprint, we also combines our Autopilot dashboard with IBM Autopilot. So we created a pull request merging our GitHub repo with the official IBM Autopilot repo. This pull request doesn't include the login implementation because NERC uses GitHub OAuth for authentication, but IBM wants to use OpenShift ID. So each cluster implements different authentication. And to do this, we created a fork of the IBM Autopilot repo, and we added a git remote of our repo and fetched our main branch into a subdirectory of Autopilot. And then this is the screenshot of our PR.
Yeah, so we also update our documentation. Previously, we just used our user instruction and interface, and now we update the login page screenshot with the currently we have with the key clock interface, and we also add some RBAC descriptions with key cloud, which also explains why it allows admin for access and restricted users from unit tests. And we also confirm the login methods currently with the GitHub, and this is the pull request screenshot.
The following is our burn down chart for the current sprint, and as shown from the actual burn down, the team spends extra hour to finish the task. And the following screenshot shows that the tasks that are completed and the one in progress, which is to set up the customized configuration. And the following are a screenshot of our backlog. So we accomplish every components that are required for this project, except for the customized configuration, which is in progress. In terms of backlog, there's one thing that we won't be pursuing, which is the OpenShift integration as our stretch goal.
In terms of challenges encountered regarding our Keycloak server deployment for the login system, any change we made on the web CLI was not persistent, so we would always have to start our server with a JSON file and a Docker file containing our specific server configuration for Keycloak. Also, something we encountered with the OpenShift deployment was that every time the dashboard app was hit, the app cannot just wait for the Keycloak server to start up a pod if it currently has 0 pods running. So therefore, the server must always have at least 1 pod running for full functionality. And this is something we had to change in the OpenShift configuration. Also, GitHub OAuth was very basic, and we could not implement role-based access control through it. So role-based access control had to be handled through the Keycloak server and the dashboard application itself.
There are also a couple challenges with installing a Helm chart. We needed to keep commit history when merging repositories because we can't just clone our repo into an Autopilot fork. And there's also a learning curve with the Helm charts as we did not have much experience working with these beforehand.
In terms of lessons learned, we learned that the Keycloak server, of course, must be configured using JSON file to save changes, as we mentioned before. However, this can be done in a much easier way by doing a partial export of a JSON through the web CLI. So through the web CLI, we can already get a partially configured JSON file, so we don't really need to make it from scratch, saving us a lot of time. Also, as I mentioned, the NERC OpenShift cluster needs to set the minimum number of pods for the Keycloak server to 1, and this can be done using the Knative configuration system that NERC uses. We also learned that that GitHub OAuth app must have a proper authorization callback URL set. If this URL is not set on the OAuth, it will give security errors and it will not function properly.
Some things we learned in regards to installing the Helm chart are that Helm charts enforce a structured approach to Kubernetes deployments, and they promote consistent resource definitions across environments. And also, us gaining proficiency with Helm charts enhanced our ability to manage and deploy cloud-native applications effectively.
Some feedback that we got from our mentors is for the login system that NERC prefers to use the GitHub for their SSO instead of give access to their login with OpenShift ID, which is what IBM wants to use. And then RBAC must be managed through the Keycloak app. And then for the installation and Helm chart, the Helm chart must be set up for Autopilot dashboard for easy installation through Kubernetes. And then also set up customized installation as well, in addition to Helm, because NERC uses customize. And then for our Autopilot dashboard repo, it must be merged to the Autopilot repository in a separate directory, which also contains the Helm chart. QA testing, we want to test to have multiple pods operating and have 1 pod to do more extensive tests. and all QA testing should be done on weekends to avoid disruptions in NERC.
So for our next steps, we plan on having the QA testing on NERC deployments for both Autopilot and the dashboard. We also plan on adding customized installation configurations in addition to Helm. We want to finish pull requests for verging dashboard with the Autopilot main repository. We will clean up documentation and refactor the code to be as readable as possible. We also want to set up the user database architecture only if time permits. This is a very low priority stretch goal because the exact login system is different. It is environment dependent on where Autopilot is deployed. To be specific, NERC wants to use Keycloak with GitHub OAuth, but IBM clusters prefer to use OpenShift ID. Address stretch goals regarding the recent test histories, only if time permits. And thank you guys for watching. Catch you guys on the next one.
Yay!